Hello and welcome to Data Analysis and Visualization with Python. This is the second video in the series. In the previous video, we just learned over general Python programming and a brief introduction on data types. In this video, we are going to be discussing two things that will be beneficial to data analysis process. First, we will take a look at lambda expressions, or as they are known as anonymous functions or temporary functions. Then we will take a look at functional programming and what is functional programming and a little bit of its details and some reading material. And then we'll take a look at an example of functional programming by implementing the map built-in function. The purpose of this content is to make you familiar with some of these things so you don't have to look them up while learning about the Python libraries. And so let's get started. First, let's take a look at what are lambda expressions. Lambda expression is a short code that takes parameters and returns a value, a function in short. Lambda expressions are nameless. They do not need a name and can be implemented in just one line. So normally we know that we define a function something like this. We use def, the name, and a parameter, and after a colon, the body of the function. Notice that the body of this function has only one expression, and that is the return statement, and a small expression here that is to be evaluated. Well, in case of lambda expressions, we can define the same function without a name. Lambda expressions are nameless, they do not need a name and can be implemented in just one line. We define the lambda expression by using the keyword lambda, then typing the parameters, x in this case, and then after a colon, the return value expression of the function or the body of the function. Just like in this case, 3 multiplied by x plus 1. Now this function is basically exactly the same as this one, but to use this function we need to assign it to a variable. So let's go ahead and do that. F equals here, and so we can use this function exactly the same as the above one, like this. So what's going on here? Well, first of all, by using the keyword lambda, we are declaring that the following function is going to be an anonymous function. Then we mention the parameters of the function. Just like any definition of a function, a lambda expression can have as many parameters and as many types of parameters as you can. And then we go straight to the body where there is only one expression, and that is the return value of the function, which is this. Notice that we don't need to use the keyword return in our lambda expression. Usually, if we define a function in this way, what usually happens is that we can write a lot of code under the definition of a function. We can use for loops, while loops, we can basically add conditional statements and whatnot. But in this case, we can't. We can only use one expression that is going to be the return value. So by the time you will be creating comprehensive programs, you may feel the need to define a function that does some specific task, but you are not going to be needing that function often. And so you may choose to not define it through the conventional form and just write it in a one-liner. This is a simpler form of defining a function. We can actually pass this defined function into other functions as well. In functional programming, we will see later in this video. So with that being said, let's pause the video here while you viewers go ahead and try to make a function in the form of a lambda expression that basically takes a list of numbers and returns a list of those numbers incremented by 1. So go ahead and try to produce a lambda function that basically takes a list of numbers, for example this, and returns a list which is basically an increment by 1 of the first list. So and try to think of a solution. And once you're done, unpause the video to see the solution. So we define a function I equals lambda x, which is a list. In this case, this parameter x is going to be a list, and in the body of the function there has to be a return expression, and so what we want to return is a list, and in that list we want all the items of the first list incremented by 1. And so what we can do is, so in a list, produce n plus 1 for n in x. And so let's suppose our list is 1, 2, 3, 4, 5, 6, and if we pass this list into our I function, which is the lambda expression that we just made, what will happen is that for each value n in the list x, evaluate this expression and put it in the list. And so if I run this, you see the input values and the output values are now incremented by 1. We can also use a lambda expression without assigning it to a variable. We can do it in this way: lambda n1, n2, these are the parameters, these will be the integers, and the return value will be n1 plus n2, right? And so if we run this right now, it will just return a function object, a definition of a function in a short sense. And so what we want to do is, right, we want to run this as we are defining it. This is a very convenient thing in Python, that you can run a function at the point you're trying to define it. So how do you run a lambda function while you define it? So what you can do basically is put this entire statement in a parenthesis, and in the next parenthesis, right after this expression, we are going to input parameters. Let's suppose the first number is 4 and the other number is 6, and now if you run this, the function is evaluated at the time you're also defining it. And so it is not necessary to assign a variable to a lambda expression before calling it. You can just call the function defined by a lambda expression directly. So those are a few things about lambda expressions. And now let's move on to a brief information about functional programming. Functional programming is a programming design where programs are constructed by making and implemented a lot of functions. It makes it easier to solve complex problems, and it's crucial in dealing with big data. For that reason, we make everything as objects and functions in a program. Functional code tends to be more concise, more predictable, and easier to test than imperative or object-oriented code. The topic of functional programming is a little comprehensive, and so I will put reading material for functional programming in the video description or in the following unit. And so an understanding of functional programming can be seen by an example of a map function, which is a higher order function. The map built-in function takes function as a parameter and iterators as second or more parameters. An iterator is basically a list, tuple, dictionary, and so on. The map function returns an iterator as well after applying the given function to all the iterators given. This might be a little complicated to understand at first, and so let's see it with an example. Let's suppose that you have a function f equals to lambda n multiplied by n. This function takes an integer and multiplies it by itself and returns it. Notice that there is only one parameter and there is only one return value, which is an integer as well. And let's suppose that you have a list x and you want to apply this function to each element in the list. Now normally what would you do is you would start a loop as follows. For I in x, result dot append f I. But notice what happens when I use the map function to do the exact same task. It happened in one line and it's showing the exact same output. So what happened here is that we basically mapped the function f to an iterable object. So the function is applied on all the data at the same time instead of doing it one by one through loops. This is extremely important while applying functions on huge sets of data, and we need to be efficient while handling datasets. Let me show you the structure of the map function. So the map function takes a function as its parameter, and all the other parameters have to be iterators. Let's comment this statement out for a second and do the exact same thing, but this time we're not gonna write print or list. We're gonna just write map f x. If you write it just like this, it does not evaluate the statement, it just returns an object. So this map right now is an iterator object. To use or see this iterable object, what we do is we can pass it through a list, and once we pass it through the list function, we can see the output. So I have a little bit of a challenge for you guys. Let's suppose you have two stores which offer the same cars but with different prices. You would like to buy all cars but at their lowest price. You have a function that takes two tuples and compares the second element of each tuple and returns a list where its first value is the store name and the second value is a tuple containing the min price from that store. The goal is to get a list which tells you which car to buy from which store so you can get it at the lowest price. Right now we have a function that compares two tuples, right? And if I give these two tuples as parameters in this line, what happens is it compares the two tuples and returns a list where the first element is the store name A, which means that we should buy but from the store A because its price is lower, right? But now this is a fairly simple function, right? But now let's suppose that instead of stores offering just one car, stores offer multiple cars, both the same but at different prices. This is a list of tuples. How can you map this function in such a way that we get a list which literally tells us all the cars that we have to buy and their stores from where the prices are lowest? So I want you to pause the video, think about it for a while and try the solution. Alright, so let's see how we can use the map function to achieve our task. First of all, we use the map function. And what function do we want to map? We want to map the cheapest product function that we defined above, and its parameters have to be iterators, right? So store A offer these cars at these prices, store B offer the same cars but at slightly different prices. This function takes two parameters, right? So let's put store A and store B here, right? Now if I run this, it will return a map object. It is an iterator. So what we want is we want a list. We want to iterate over this object and create a list. So let's put function list here. And now if we run this, we can see that we get a list where it basically tells us that if we are to buy BMW, buy it from store A because it's cheaper there. If you want to buy Kia, we should buy it from store A because it's cheaper as compared to store B. However, so you get the idea, because store A right now, for example, if you look at this value, it offers BMW for 83,000, which is more, right? And we want all the cars but in cheaper value, which is in store A. So what I'm gonna do is I'm gonna put a lot of reading material unit or in the description of the video. So before moving on to the next video, I would recommend that you guys read more about these things, because in the next video we are actually starting with the Python library NumPy. And so with that being said, thank you very much, and I'll see you in the next video.